Hello students, in this video we're going to discuss about standing waves in closed and open organ pipes. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share it to friends, inspire me to create new contents for you and help me to grow my channel. And if you get the hype option, please do hype the video. Okay, and if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT 123. That's my Insta ID. You can follow me on Insta. So now let's start. So here it is a closed organ pipe. Closed organ pipe doesn't mean that both ends should be closed. Okay, only one end should be closed. Okay, and wave is traveling in this direction towards the end of this organ pipe, and it strikes the end and it reflected. Okay, this wave is reflected from this boundary, okay, which is closed boundary, and then it travels in this direction. Okay, so coming in this way from right to left, then it is going left to right, and as a result as a result of superposition of these two incident and reflected wave, standing waves will be formed. Okay, right. So let me consider that the wave moving from right to left. Okay, suppose the wave moving from right to left be given by, suppose s1 x comma t is equal to s sine omega t minus kx, right? Let me consider that way. Okay, this is moving from left to right through air. Okay, through the air column inside this pipe, through air, right? And the reflected wave moving from left to right is given by s2 x comma t is equal to s sine. So here now direction is changed, so omega t, instead of minus kx we're going to write plus kx, and it is change, it is reflected from a rigid boundary, closed boundary, so there must be a phase change, and that change in phase be suppose given by pi. Okay, so hope you have understood this. So now according to the superposition principle, the resultant wave is, let me write, s is equal to s1 plus s2. That will be given by s1 plus s2, right? Now here you can see that s1 is equal to a sine omega t minus kx, and plus s2 is a Now here you see this pi plus this one. You know that sine pi plus theta is given by minus sine theta, right? Hope you know this. If you apply the ASTC rule, then this is pi plus something, means it is in the third quadrant, which is the quadrant of 10, but now we have sign here, so there should be a negative sign, and pi is 2 into 90, so even number into 90, sign remains sign, right? So if we apply that, then what we can write here you see this can be written as a sine, there will be a minus sign, omega t plus kx. That's what we can write. Hope you have understood this. So instead of s2, we're gonna put this result here, you see. So let me write instead of s2, so here positive negative, it becomes positive negative, sorry. So hope you have understood this. Then let me copy this step and let me go to a new slide. Okay, let me take a new slide. Okay, so here is the new slide, and this is the last step that we have done. So now hope you know this identity that you have got in trigonometry, that sine c minus sine d is equal to 2 cos c plus d divided by 2 and sine c minus d divided by 2. Hope you know this identity. If we apply that, considering this is 2, if we consider if we take common, right, if we take common a, then we can write here sine of omega t minus kx minus sine omega t plus kx, right? And now apply this identity. Let me write this identity here, just give me a second. Okay, so considering this one as c and this one as d, sine c and sine d. Okay, hope you have understood this. So if we do so, then what we're gonna have, you see, sine according to this identity, 2 cos c plus d, 2 cos c plus d, here c is omega t minus kx and plus d, d is omega t plus kx divided by 2. Here minus kx plus kx gone, omega t plus omega t, that will be 2 omega t, and 2 will be cancelled. So here we can write a cos omega t, then one more part is there, then into sine c minus d, here c is again omega t minus kx minus d, d is omega t plus kx. If you remove the bracket, then what you're gonna have after multiplication of the minus sign, so you're gonna get omega t minus kx, right, divided by 2. Here minus kx, sorry, not minus kx, omega t gone, minus kx, that's going to be minus 2 kx, again minus again 2 cancel, so we end up getting minus 2 kx, sorry, minus kx, sine of minus kx. And we know here we can write sine of minus kx. We know that sine of minus theta is minus sine theta, right? We know this. Hope you know this. So if we use that, then this then the final expression will be of this form. So let me show you. So minus a sine kx omega, sorry, cos omega t, and this part is the resultant amplitude of this resultant wave. Okay, so hope you have understood this. So this is the amplitude of the resultant wave, Hope you have understood this. Now you see, okay, let me use this result, let me copy this and let me take a new slide again. Okay, so here is the last step that we have got. Now let me draw the organ pipe. Okay, so this end is suppose x is equal to 0, and this end is suppose x is equal to L. And remember one thing, that at the close end there will be always node. Okay, not antinode. Node is formed at the close end. Okay, and this is the first mode of vibration. Okay, this is going up and down. Okay, like here is the position of node, and here is the position of antinode. Now yes, here you can see that at the close end of the pipe, at the closed end, we know that x is equal to 0. At x close end, x is equal to 0, and sine kx means sine 0 here, and sine 0 degree is 0, right? That's going to be 0. Okay, so in that case amplitude is also this amplitude becomes 0. As a result node is formed. Okay, as a result we're going to have s is equal to 0, so node is formed at x is equal to 0, right? Now you see at the open end, you see x is equal to L. The open end at x is equal to L, antinode is to be formed. Okay, at the open end always there will be antinode. Okay, so to get antinode there, here you see this, at this position s is equal to L, and here the value of s is maximum here. Okay, which is equal to the length of the pipe, and this is possible when sine kx is equal to plus minus 1, either plus 1 or minus 1. If sine kx is equal to plus 1 or minus 1, and we know that sine of twice n minus 1 into pi by 2, sine of twice n minus 1 pi by 2, where n is equal to 1, 2, 3, dot. Okay, if you put 1, 2 and 1, 2, 3 and so on in n, then you're gonna have a value of this alternatively plus 1, minus 1, plus 1, minus 1, right? Hope you have understood this. So now if you put here n is equal to 1, then you're gonna have twice 2 into 1 minus 1, that's gonna be 1 into pi 1 into pi by 2 is pi by 2, so sine pi by 2 is we know that is equal to 1. So if you put here 2, if you put n is equal to 2 here, that's going to be 4 minus 1 pi by 2, that's going to be 3 pi by 2. 3 pi by 2 means pi plus pi by 2, right? Pi plus pi by 2, and sine of this, sine of pi plus pi by 2, sine of pi plus pi by 2, if you apply the ASTC rule, so this is pi plus pi by 2, that's going to be in third quadrant, and that's going to be minus sine pi by 2, and again minus sine pi by 2 is minus 1, right? And so if you keep putting those values of n, you're going to get alternatively plus 1 and minus 1, right? Hope you have understood this. And here you see sorry, this is not s is equal to L. This s must have the maximum value. Okay, here x is equal to L, so put the value of x. So sine KL is equal to sine of twice n minus 1 into pi by 2, right? Hope you have understood this. So now here you see okay, so comparing both side, left hand and right hand side, we can write that KL is equal to twice n minus 1 pi by 2, and this value of k is, we know that that is 2 pi by lambda, 2 pi by lambda here into L is equal to twice n minus 1 pi by 2, right? So here you see pi cancels, so let me copy this step and let me go to a new slide. Okay, so here is the last step, and if you simplify this, you're gonna have lambda is equal to twice after cross multiplication there will be 4L by twice n minus 1. That's what we're gonna have, right? Hope you have understood this. Okay, now let me copy the figure of this first normal vibration, normal mode of vibration. So here is the figure. Okay, now you see, just give me a second. Okay, just give me a second. Okay, now you see, for the first normal mode of vibration, so we're gonna put n is equal to 1, and then we're gonna get lambda 1. Let me write lambda 1, that's gonna be 4L 2 into 1 minus 1, that's gonna be equal to 4L, right? So lambda 1 is equal to 4L, and hence L is equal to lambda 1 by 4. Let me tell you why. You see, if you observe this, this is not complete wave. Okay, so you can complete the wave like this. So just if you see this diagram, this is of this form. This is the suppose organ pipe, and only this portion of wave is there. So if you complete the wave, it should be like this, right? This is the wave. Okay, so here you see, you can divide it into 4 parts. Okay, right? So only 1/4, this is 1 part, this is 2, this is 3, this is 4, and only 1 part out of 4 is there, which is inside the organ pipe. So 1 out of 4, that's why lambda 1 by 4, right? Hope you have understood this. Okay, now you see frequency. New one, we know that frequency is equal to speed of wave divided by wavelength. Hope you know this relation, right? So you know that speed is, suppose we have taken v here, and lambda 1 is equal to 4L. So let us put here 4L. This value is to be put written here. Okay, so here v is the speed of the wave, right? So now you see here, this is called the fundamental, this is called first harmonic, or fundamental frequency. This is called fundamental frequency. Right? Hope you have understood this. Or first harmonic, or first or fundamental note, or first harmonic, or first harmonic. Right? So now for the second mode, you see, for the second mode, this is x is equal to 0. Here it is x is equal to L, and second mode will be this of this form. Let me take the next slide. Okay, let me take the next slide. Okay, here is the organ pipe, and let me copy the expression for lambda. Here is the lambda, you see. So for the second mode, second normal mode of vibration, second normal mode of vibration, we're gonna put n is equal to 2, then lambda 2 will be equal to 4L divided by 2 into 2 minus 1, that's going to be 4L by 3, right? That's what we have got. So therefore frequency nu 2, that's going to be equal to V divided by lambda 2. So V remains V, and lambda 2 is 4L by 3. So if you simplify this, then you're gonna get 3 times of V by 4L, and V by 4L is nothing but nu 1, right? So 3 times of nu 1, because nu 1 is equal to this. Okay, so V by 4L is replaced by nu 1, right? Hope you have understood this. So similarly, we can find nu 3, and in order to find the nu 3, first we need to find the lambda 3. So lambda 3 is going to be equal to 4L divided by 2, 3 is 6 minus 1, that's going to be 5. Okay, so nu 3, that's going to be equal to V by lambda 3, and if you put the value of lambda 3, then you're going to get 5V by 4L, and that means 5 times of nu 1. And similarly nu 4 is equal to 3 times 5 times, then 7 times. Next one will be 7 times. Okay, 3, 5, 7 and so on, right? So that's how we're gonna have. So for for n equal to n, what we can write, you see, for nth mode of normal vibration, so we're gonna get nu n. You see, this 5 can be written as 2 into 3 minus 1, and this 7 can be written as 2 into 4 minus 1. Similarly, if there is nu n, then we can write 2 into n minus 1 into nu 1, right? Hope you have understood this. So that's how we can do. Now what happens in case of let me draw the second mode of vibration here. Second mode will be of this form. Now you see, in second mode, so we have got lambda 2 is equal to 4L by 3. That means from here L will be equal to 3 times of lambda 1 by 4. Sorry, not lambda 1, lambda 2. So if you divide a wave which is whose length is lambda into 4 equal parts, okay, so out of that 4 equal parts we have to take 3 parts, then it will be equal to the length of the organ pipe. So that means this portion of the wave will be inside the organ pipe, but rather taking this portion, we're gonna take from here, okay, 1 part to 3rd, okay, because here we're gonna get node, right? So this part should be there. Okay, this is not complete wave. Hope you have understood. This is 3/4 of the wave. Okay, so let me make dotted lines. Here we're gonna get antinode, here it is node, again antinode here. Okay, so hope you have understood this. Similarly, we can obtain the 3rd mode, right? Okay, now what happens in case of open organ pipe? Let me take a new slide. Okay, uh, let me take a new slide. So here open organ pipe, here both ends are open. Okay, this is x is equal to 0, this is x is equal to L. In case of open organ pipe, you know, at the both open end there will be antinode instead of node, right? So first mode of vibration will be of this form. Okay, this will be the form of first mode of vibration. There will be a node here. Okay, this is position of antinode and this is also position of antinode, right? So standing wave in open organ pipe, in case of open organ pipe, okay, first mode of vibration, so here you see, if you imagine the complete wave like this, this is lambda, and you see, if you divide this lambda into 4 equal parts, right, this portion of this wave, 2 out of 4, that means half of the wave is inside this pipe in the first mode. So we can say that L is equal to lambda 1 by 2. Okay, so in the first mode we can say that L is equal to lambda 1 by 2, right? So which means that lambda 1 is equal to 2 times of L, right? Hope you have understood it. If that is the case, then frequency of vibration will be nu 1 is equal to, let me write it nu dash in case of because in case of closed organ pipe we have written nu, so in this case let me write nu dash. Okay, so that's going to be equal to you know, again v, speed of the wave, divided by wavelength lambda 1. Here lambda 1 is 2 times of L, so let me put 2 times of L, right? So here one more interesting thing, that you can write this as 2 times of V by 4L, right? Why I am writing this, let me explain. If you cancel this 4 by 2, then you're gonna get this again. So now you see the cause of writing the frequency in this form. If you remember, let me go back to the you know, previous slide, not this one. Let me show you this. Here you see the first fundamental frequency of the, you know, in case of closed organ pipe was you know, V by 4L, right? V by 4L, which is equal to nu 1, right? So now you see, as in closed pipe, that we have got nu 1 is equal to V by 4L. So here, from here it is clear that frequency of vibration, that you know, fundamental frequency of vibration in case of open pipe is 2 times the, you know, fundamental frequency of closed organ pipe, of frequency fundamental frequency of standing wave in closed organ pipe. Okay, since nu 1 is equal to V by 4L, this is the fundamental frequency okay, in case of closed pipe, right? Hope you have understood this. So let me write let me take a new slide. Okay, let me copy this, all this steps that I have written here. Okay, so now you see, at the open end we must get antinode, right? So just give me a second. So if you observe the pattern of this first mode, let me copy this one as well. So in the first mode, so we have got antinode here and here. In the second mode, we must have get 3 antinodes. Okay, 1 antinode should be increased. So that's why the wave pattern, this wave inside it should be of this form, right? In this case, you can see clearly that you see. So here we will get 1 more antinode here. This is node and this is node, and here you see, if you observe this wave, you can see this wave. This is crest and this is crest, right? So this is crest, here it is crest, and here also it is crest, right? So that's why crest to crest. So this length is lambda. So here wavelength is suppose lambda 2. Okay, in this case. So we get here for the second mode of vibration, normal mode of vibration, lambda 2 will be equal to L. In the first mode, the lambda, which one is lambda 1 is equal to, what was the lambda 1? Twice L. Lambda 1 we had got twice L. Now lambda 2 is equal to L, right? Lambda 2 is equal to L. Then this L can be written as 2 times of L divided by 2, right? So if you see the pattern, this lambda 1 is equal to 2L, means we can write 2L by 1, and lambda 2 is 2L by 2. So similarly we can obtain lambda 3, that's going to be twice L by 3, and so on. That's why lambda n will be equal to 2 times of L divided by n, right? Hope you have understood this. Similarly we can find nu 1, nu 2, nu 3 dot 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 nu n as well, right? Okay, so thank you for watching. See you in the next video. Bye bye.